All right, we are going to now dissect a pig, which is another vertebrate animal. This is the dorsal side here and ventral side here. This is going to be slightly different because it has a different diet than the frog and a different metabolism. So the size of the organs might be a little bit different, and it's also a mammal. So we'll point out some differences as we get to them. One thing that's different about a pig is that even on a fetal pig like this, you can tell the biological gender from the external anatomy. And on a pig, which you look at, is on the ventral side. There's an umbilical cord here where it was connected to the mother. And on a male pig, the urogenital opening, so the common opening for excretory and reproductive tracts, on a male is next to the umbilical cord, and on a female, it is just below the anus here. So on this one, if you look back, there's the anus. There's not another opening in front of that. And up here by the umbilical cord, that is the urogenital opening right here. So this is a male pig, and that is how we identify the gender of a piglet. We're going to open it the same way we did the frog, with a single longitudinal section along the ventral side, except that because of the urogenital opening and the umbilical cord being in the way, we can't make a single cut the full length of the abdomen. We'll have to make a Y here on either side of that structure. So if we start at the front of the abdomen, make a cut through the body wall back to here, we'll have to make 2 cuts from here back on either side. And then again, once you can get into the body cavity so that we don't cut the internal organs, I use scissors. To open the body cavity all the way back to the dorsal side. And up to the front of the rib cage, at the very front end of the thoracic cavity. And at the back of the ribs to separate the abdominal and thoracic cavity. We'll make a second cut here. And I'll repeat the same pattern on the other side of the animal. Just in front of the hind limbs. And then we will pin the body cavity open. We'll start to look at the same organs and look at a couple of differences from the frog. Secondary cuts at the front of the thoracic cavity so that we can open that as well. And cutting membranes so that we don't tear any internal organs that we want to look at later as we open the body cavity. All right, so we'll start again with the diaphragm in the center, which divides the abdominal cavity from the thoracic cavity, the 2 sections of the body cavity. The diaphragm on a pig is of proportional size, is much thicker. pigs have a faster metabolism than the frogs, and so they need to breathe more because they use more oxygen. And so the muscle that you breathe with, the diaphragm, is a bit thicker on this animal. In front of that, we have a lung on either side, again, because they do more rapid metabolism and need more gas exchange. The lungs are larger and a little bit more complex than on the frog. And then in the center, again, to support a faster metabolism, there's a proportionally larger heart here, and there is a membrane separating those organs, the heart from the lungs. I've cut the top of it open already so that we can see the heart, but that is the pericardium. There's a barrier to keep any infections or get anywhere else in your body from getting to your heart, and that's this membrane right here. Going below the diaphragm, again, the organ nestled right against it is the liver. Also quite a bit larger, especially in a fetal pig, than on the frog, because that's actually where the blood vessels that come from the umbilical cord go. So this is its primary metabolic organ rather than the stomach when it's in utero. You can see that blood vessel right here, connecting from the umbilical cord to the liver. Now, so that we can look at the rest of the abdominal cavity, I'm going to cut that so that we can move the urogenital tract out of the way. On the back of our liver, there's a gallbladder right here as well. It's not very inflated on this particular pig. And it connects down here through the bile duct to the junction of the stomach and small intestine right here. Again, connected to that same junction by a duct that is kind of beneath us here is the pancreas, this organ right here. It's kind of thin finger-like organ. It wraps around, and on the back side of the stomach right here is connected to the beginning of the small intestine. Now, the small intestines are much longer than in the frog, and that's because of a different type of digestion and different amount of digestive enzymes. The absorption area has to be much bigger on a pig. Again, if we separate the small intestines from the other organs in the body cavity, just so that we can move them out of the way slightly, we'll be able to see a little bit more of what is happening behind them. Not cutting through any of the organs, just the fascia or connective tissue that holds them in place in the body cavity so that we can move them out of the way. In the very back, there are two bulges that are kind of hidden behind another layer of membrane and against the dorsal or back side of the abdominal cavity. If we take that membrane and lift it away, we can expose a kidney. That's this structure here. And on the medial or midline side of the kidney, in here, it is connected to a ureter, which they are buried pretty close to the back of the abdomen, but we can expose those slightly right here. This ureter connects up here to this kidney, and there's one that's doing the same on the other side here to the other kidney, and then they connect here to this bag on the back of the umbilical cord and reproductive organs there, which is the urinary bladder, and then that connects up here to the urogenital opening. The reproductive organs are down behind the bladder and connected through a second set of tubes inside here to the urogenital opening as well. Now we'll go back to the front of the thoracic cavity and look a little bit more closely at the anatomy of a heart. This one we will attempt to clean up, but this, you see there's a lot of this dark material inside of the abdominal cavity and the thoracic cavity. That is blood. So this piglet, when it was fixed, its blood coagulated and stayed in the body and didn't drain. So it may be a little bit difficult to see what's going on inside this heart, but we have a backup if this one does not look good. So I'm going to do the same, where I'm going to remove the heart from the pericardium, trying to keep as many of the bases of the blood vessels connected to it so that we can demonstrate where blood enters and leaves the heart. As possible. A small piece of lung tissue there that we'll have to move off of it. And so here we have the ventral view again. So this is the position that it was in the body cavity. This is the anterior end and the posterior end of the heart. And if we rotate it around and look at the dorsal side, here is a small piece of lung tissue, which I will remove so that we can see the blood vessels more easily. And there are some large blood vessels on one side here that we will talk about, and some other large blood vessels on this side as well. So on the front of the heart, you can see a barrier that runs down angling across the front of the heart here, and then two more here and here. This barrier dividing it vertically is the atrioventricular junction. So these up here are the left and right atria. I got my left and right mixed up. This is the left atrium and this is the right atrium. And this side of this middle muscle right here, this is the left ventricle, and this slightly smaller side that doesn't come down to the end is the right ventricle. We're going to resect this heart as well so that we can look inside of it. I'm going to make what's called a rostral incision that cuts across from the front. So that we'll still have a dorsal and a ventral view, but we'll be looking at the inside of the heart instead of the outside. So here we are now looking towards the back of the heart here. So this is our ventral view, and this is the dorsal view as if we were looking through the back of the animal. There is blood coagulated inside the chambers that I will try to remove some of so that you can see that it is actually an empty space in the muscle. So this is a pocket here, and this is another one down below here. Those are the right atrium and the right ventricle. The right atrium here is connected through a very large, thin-walled blood vessel, which cleaned up nicely right here, that has a vertical orientation outside of the heart here that connects to all of the veins in the body. This is called the vena cava. Blood drains through that and into the right atrium. It passes through a valve that is somewhat hidden in the tissues here, into this chamber right here, which is the right ventricle. When that contracts, the excurrent for that, or the way that blood leaves that portion of the heart, is through the pulmonary arteries which are on the back side of this, not very visible. And they split and go to the two lungs. Blood drains back from the lungs into this chamber right here, which is the left atrium. Again, it has a chunk of coagulated blood inside of it that we will remove so that you can see that it is actually a chamber. There we go. And when the heart contracts, blood flows through this structure right here, which is the bicuspid valve, into the left ventricle, which is the biggest, muscliest portion of the heart. And when that contracts, blood leaves through this tube right here, through another valve, into what is called the aorta. The aorta opens, the other end of it is right here. So it comes up, curves around. Some smaller blood vessels leave it and go up to supply blood to the brain and the forelimbs, so these legs up here. And the rest of it goes down through the abdomen and supplies blood to the internal organs and to the legs. So this is pushing blood out to the whole body that's been oxygenated by the lungs, and that's why it's the biggest, muscliest part of the heart. So you notice that this heart has more chambers in it and is more complex than that of the frog. It's a little bit more efficient to support a metabolism that is quite a bit faster. All right, and that is our pig.